This concept right here of eliminating entire terms is going to be more and more important as we move forward of being able to decide, should I divide or should I subtract? Now I want to show the contrasting examples of what happens with this because we're going to need to make a decision with our equations on which of them to do, and you'll see both of them come into play. If, for example, on this one I divide by 3, 3x divided by 3 leaves us with just x. If I subtract 3x, and I'm going to make sure they're like terms right here so that I can add and subtract, 3x minus 3x is 0. So eliminating entire terms, let's talk about this for a second. Right here you'll notice that we have the x left over, whereas on this side we're left with 0, so every part of this is gone. Same with all of these. If I divide by 5, we're left with x. If I subtract 5x, we have 0. On this one, if I divide by negative 10, we're left with x. On here, I'm going to choose to add because it's negative. Add 10x, we're left with 0. So our decision relies, do we want to leave the x there, or do we want to eliminate the x entirely, whether we divide or subtract? Let's take a look at a couple of example questions where we'll have to think about both of those things at the same time. Now you'll notice we have variables on both sides of the equation. That's the difference between what we've been doing before and what we have now, and why we have to think about this. We need to get these on the same side, and for example, if I divide it by 2, I still have the p left on this side. So I don't want to do that. I want to get rid of the p on this side so that I can combine it with its like term. In order to do that, I'm going to subtract 2p to get me 0. And whatever I do to one side, I need to do to the other side, and now we can see that our like terms are together. So I am not going to choose to divide on this. I am going to choose to subtract because I want to eliminate this term completely. That's why we just had that last discussion. 5p minus 2p ends up being 3p. We still have this minus 9. And we still have the positive 12 over here, and now this looks like what we've been working with before. So let's get this 9 over there, and we'll add and subtract. So you notice that we're using addition and subtraction now on terms that have variables and terms that don't. We're left with 3p equals 21, and now we do want to leave the p, so we're going to choose to divide by 3. So we get p equals 7. So in one place we chose to subtract because we wanted to eliminate the entire term and get the p on the other side. On this one we chose to divide because we wanted the p to stay and get it by itself over on the left-hand side. Let's do one more example right here. You'll notice again that these are on opposite sides. That 2x, let's get it over here with that 3x. It is currently negative, so I'm going to add 2x or undo that subtraction. That gives me 0, and I'll add 2x to the other side to combine these like terms. 3x plus 2x equals 5x. Still have that 15 left over here, and now we're going to choose to divide because we want this x still to be on that side. So we'll divide by 5, and we get x equals 3. So again, we chose to add because we wanted to eliminate the x completely, and we chose to divide because we just wanted to eliminate this coefficient, the 5, out in front of the x. So that decision will be important moving forward. You'll see these in all of the questions that we're working with, and you'll have to decide, do I want to turn it into a 0 and eliminate everything completely, or do I want to turn it into a 1 right here and leave the x by itself? Thank you.